Good morning, everyone. How are you? Is everybody awake? Yeah, I'm not, so wake me up if I fall asleep. So, although the science of bulk solids has been around since around, the 50s, 60s when Dr. Janicki developed it, there's still a lot of myth going around and not enough confidence in the science, and there's still a lot of trial and error. And as a consultant, I see a lot of these myths when I go out to plants and try to solve customers' problems. So we figured we'll do a little hybrid of magic show / mythbusters for the show today. And so I'll touch upon a few of the myths that I encounter very often. And just to be warned, I am going to pick on you to come up here and help me out because I'm going to need somebody to help me. So I will ask you that if I point at you, don't resist me because I will come and drag you out up here. So just voluntarily come up when I say. So if you just do what I say, we'll have no problems. Okay? So the first myth that I say that I run into is, when I ask the customer, it's like, well, what are you handling, right? And they'll tell me, flour, fly ash, cement, sand, clay, and I'm like, okay, great. We need to figure out what the flow properties of that material is. And they're like, well, but it's fly ash. What do you mean you have to measure the flow properties? It's fly ash. You've tested fly ash before. You know what it looks like. And it's like, well, yeah, but not your particular fly ash. Even with sand, people say, well, it's sand. How difficult can it be? And it's like, well, there's different aspects that control the flow properties. There's aspects like chemical composition, particle size. If you want to, I was just talking to somebody at the booth, talking about, having really tight particle size controls where they need to have a mix of 20-40 sand, and if they get too much 20 or too much 40, their process downstream is all screwed up. So you need to realize that the flow properties are very imperative. And so I was going to show you this myth of sand is sand, and so I'm going to pick my first volunteer, and if you raise your hand, then I won't have to pick. So who wants to come up here? Come on. There you go. Here you go. Oh, we have two. Awesome. Come on. Can I get Hi, Andres.
Sean.
What's your name?
Sean.
Sean?
Morgan.
Morgan? And who are you with?
Alvaro.
Okay. And what do you do?
Production engineers.
Production engineers? Both of you? Okay. Do you know sand?
I've played with it.
You've played with it? Yeah? Okay. So here's what I'm going to do. I'm going to have you guys, and Morgan, you can hold the funnel. And Sean, you can fill the funnel with the sand and use a spoon. Now, before we do this, does this look like sand?
It does.
Is it something that you've seen before?
Yes.
Is it anything special?
It's pretty sparkly.
It's pretty sparkly? Okay, so we have sparkly sand. So let's put it in the funnel and see what happens. And don't be afraid, you can dump the bucket on the funnel. It'll be fine. Morgan will survive, hopefully. You guys signed the liability waiver? Yep, keep going. Don't breathe, get silicosis. There you go. Make a mess, don't worry. We're not here to clean it up. So, let me ask you a question. What would you classify this as? Is it easy to flow? Is it not easy to flow?
I'd say it's pretty easy.
Is it pretty easy?
Seems to be.
Yeah, okay. All right, so let's see what happens when you lift out the cone. Okay, describe the flow. What happened?
It fell out pretty fast, but you can definitely tell that there was some friction in it.
There's friction in it, okay. Did everybody see that? You just lifted out the cone, sand came out, no problem whatsoever? Yeah? Okay, so free flowing sand, right? Sand is sand. So let's do this. Can we put the sand back in the bucket, please? Come on. You're an engineer, figure it out. You can, wow, look at that. You're thinking now. Good. Here, let's put the, because, yeah, we don't want to make too much of a mess because otherwise Aaron over here is going to make me clean it up. And see, Morgan's thinking. What did you say?
A lot of dust.
A lot of dust, yes. We should have had dust masks. Let's put that on the list for the next show. Okay, so now let's add some water. Yep, into here, yep. You ever did this as a kid?
Yep.
Add water to sand, yeah. That's good. Ooh. It's a lot of water. Okay, yep, mix it up, mix it up. Don't break the spoon, because otherwise you're going to charge me. It's a borrowed spoon, so. Still have some at the bottom there. Okay, is that good? You know what we should do? We should just dump some of that water off. Ooh, look at a mess, wow. Is that drain enough? Yeah? Is it way different than before?
It's pretty heavy.
Yeah, pretty heavy? Yeah. Let me just do something, because we added too much water, so we're just going to drain some, because otherwise my experiment's not going to work and I'm going to blame you. So we don't want that. We don't want to blame you. We just want to help you out. Yeah. There you go. See, I like you. You're in management potential. We'll just blame Sean. Okay, Sean, it's your fault. Hey. Let's not point fingers. So let's do this again. Funnel. And just dump the... Would you say that's free flowing? No, you would not. There you go. Make a mess. You're smart. You picked the dry sand for your experiment and you made a mess with Sean. Good. See, you are management. Okay, so now, Sean, lift up the funnel. Well, what happened? Yeah, vibrate it. Yeah, that's just what. Get a hammer. Get a hammer. Yeah, who has a sledgehammer in the audience? Come on. So that's usually what happens at the plant, right? So what changed, right? It was the same exact sand. What was the only thing that we added? Water, right? So just by changing the moisture content, we went from a easy to handle, free-flowing material down to a, we can't get it out of the hopper. We couldn't even get it out of this non-convergent, it's actually a little divergent on this thing, and we couldn't get it out of here, right? So just when you say sand is not really sand, right? Thank you, and applause please. You can go back to your seats. So who is an engineer here? Yeah? You go to grad school at all? No? Just undergrad? Okay, good. Did you ever get a class in fluid mechanics? Fluid mechanics? Yeah? Yeah? Gas dynamics? Yeah? Heat transfer? Yeah? Mechanical design? For those Meckies in the audience? Yeah? Mass transfer, chemies, raise your hand. Mass transfer, yeah. Did you ever get a class in solids handling? Did you even know that solids handling existed when you were in school? Yeah, you did? Awesome. How do you know?
Well, we had classes. I guess when I was in school, we did have classes where we measured the angle of repose and things like that of some bulk solids.
Okay, I wouldn't brag about that, but good. We measured the angle of repose, which, by the way, it's not very useful, but it's something that we measure. So the next myth that I run into a lot is when we design tanks to hold solids, a lot of people just apply liquid laws to hold the tank. So the pressures that they calculate on the tanks are based on hydrostatic pressure, which is not appropriate. What is the fundamental difference between liquids and solids? And Morgan alluded to this when she was up here. You did. You didn't know you did, but you did. Yeah. Friction. Who said friction? What's your name? You're my de facto next volunteer, so come on. So friction. There is not only friction with the container, but internal friction. Particle to particle friction. We don't talk about molecule to molecule friction in water. What's your name?
Clark.
Clark. And you are with?
Albemarle.
Almer. And what's your job?
I'm a TR engineer, so it's a resource technology.
Research technology. That's good. Can you clarify? Because I don't know what TR engineer is. Okay, so what we're going to do, and we're going to get messy. And actually, since you're up here, we need to be safe. So here we go. So everybody sees you. There you go. And you have glasses, but not safety glasses. Fit over the, yeah, maybe. Okay, oh, you didn't see, great. We're gonna do this blind. This should be fun. Okay, so what we have is, what is this?
An egg.
An egg. Anything special about the egg?
Nope.
No? Would you make a scrambled egg for this?
Absolutely.
Okay, so hold this. Here we go. So we have this column, plexiglass, everybody see? Yeah, we have a bag at the bottom. And what we're gonna do is we're gonna put water on the egg. But before we do that, who's got a pen and a pencil? A pen and a paper. Okay, so you're gonna write the next time I'm gonna give you. So we have some water, and we're gonna measure the weight. Okay? And Mark, was it? Clark. See, I was seeing if you were paying attention. So Clark is gonna give you a number, 4.65 pounds. Okay? 4.65 pounds. So now what we're going to do is, with your help, we're going to put the egg right at the bottom of this. Right on the grate. So this is really going to make a mess. We have a platen at the bottom, and we're just going to lower this down to rest on the egg, but not crush it. Okay? Good. Do you mind tightening that? That's really your job, dude. Come on, help. Okay. You think that's pretty loose? Oop, too loose. Okay, lower it down a little bit, just make sure that the egg doesn't fly into Haley over here, because she looks nice. She doesn't want to get egg in her face, yeah. I mean, it'd be funny for all of us, but Haley wouldn't like it. So here we go. Okay, so your job now, because I don't want to make a mess of myself. I don't mind you making a mess of yourself, and you're pretty tall, so you'll be fine. So you're going to take this water and dump it on the column, and we're going to see what happens to the egg. I can see myself getting... There you go. It worked much better at our lab when we did it, so we're gonna blame it on Clark. So what happened, right? Did anybody figure out that was gonna happen? Was that surprising to anybody? No, you pretty much expected to crack the egg, right? So there wasn't anything really out of place there. Because what we expect is for the loads to get transferred toward the bottom of the bag. And that load to be transmitted to the egg and therefore crack the egg, right? So that wasn't surprising. Now, since there is no internal friction, right, and there's no motion against the wall, so to speak, there's really not real friction between the water and the container. So everything is get transmitted down to the egg, ergo crashing the egg. You're not free yet, so we're still working. Unless somebody else wants to come up and help me out, because we want everybody's involvement. Sorry, man. I was trying to get you off the hook, but... So here we go. So now we have this, and we're going to put the same volume of sand on this, on the egg. So we have this, and thanks, Joe, for helping out. So here we go. This is the sand. Let's dump the, actually before we do this, because we don't want cohesion, so we're going to dry off the bucket, so we don't get this cohesion effect that Morgan was kind enough to demonstrate earlier. So here we go. So it's dry. Is it dry? Yeah, dry enough. Okay, good. So here we go. So we have sand. Does it look like regular sand? Is it any kind of special sand? So It is sparkly, yes, as told by Sean earlier. So we have sand, just same regular sand. So you be so kind and dump that sand in the bucket, please. And here, I'll help you. Here, listen to this. And watch out, because it's dusty. Until the red line, please, because it's the same volume. See, if he knew what the angle of repose was, it's not flat. So that's why he has to shake it a bit, give it a little shake, a little twist. That's good enough. It's close enough for horseshoes and hand grenades. Okay, so what was your name? Sterling. Okay, Sterling. We're going to read off a new number to you and you're going to write it out. Okay, Clark. Tell Sterling what the weight of this sand is.
7.8.
7.8. What was the weight of the water? 4.65. Is 7.8 greater than 4.65? Yeah? Okay, it's been a while since I was in school, so I don't know. Okay, so now here we go. And this is? An egg. Okay, so we're going to do the same thing. We're going to put it under there. We're going to lower the little column to be closed so that the egg doesn't go flying. Is that in there? Okay. So here we go. We're going to do the same thing. I'm going to dry this off a bit. I'm going to make a mess of my rug. That's okay. So, what's everybody's prediction? We're going to crack the egg? No? Who says no? Wow. Who says yes? Okay, here we go. Who's got the betting? Who's got the over-under on the cracking of the egg? All right, my friends, here we go. We're going to dump those sand now. Just so that you don't see that. Okay, so it's bottom platen is completely free. The whole weight of the sand, which was what? What was it? 7.8, which according to Clark is much more than 4.6. Right, so a lot more weight, same volume, sand versus water. The egg is not cracking. Was that a super strength egg? Was it titanium coated? No, it was just a regular egg. Yeah. So just a regular egg, and oh, see, almost went flying towards you, Haley. So why did it not crack? What was the fundamental difference between solids and liquids? Friction. So we have friction between the sand and the tube. So that friction is actually holding up some of that weight. So not all the weight of the sand is transmitted down to the bottom of the egg, right? So that's what friction does for you. So I think we're done with you. Thank you so much, sir. Yeah, round of applause, round of applause. So now I need 2 volunteers, and we're gonna have a little shake-off. And I should have told you that, because now nobody's gonna come up. So 2 volunteers, come on. Don't make me pick on you, because I will. Since I know you, John, you're the first one to come up. Come on, I need one more.
We're also here. I didn't see it.
I need one more. There we go. Here we go. Okay, so we have 2. Okay, so this is a little challenge. What's your name, sir? Allie. Good to meet you. John. Good to see you again. So we have Allie and John. Now, this is a little challenge, and it's going to be a competition. So I want to separate you both because I don't want elbows flying. I don't want things to get out of control here. But but so we have this tube filled with sand. Okay. How much time do we have? Oh, you got plenty of time. Filled with sand with a ball bearing inside. I did some research. back then YouTube wasn't that in vogue, so there was no YouTube videos to look at, and I could not figure out. It was about 2 weeks, 2.5 weeks of doing stuff like that. And after 2.5 weeks, I was like, I give up. I can't do it. I almost quit. My doctor, thank goodness I didn't. And then I went to my thesis advisor and said, Haley, not you, Haley. My thesis advisor was named Haley. Haley is like, how do you do this? And she showed me, well, I'm going to show you in a little bit, but I want to see you struggle more. Okay. Did we know which one was started? Oh, okay. Okay, all right, good. Okay. So she explained to me what the difference was, and this is segregation, something that a lot of you folks see every day. It's a separation of particles by size, not necessarily by density, not necessarily by shape, but mostly by size. And what you need is a free-flowing material with the size difference as small as 1 to 1.3. So the ratio of the large to the small could be a 1.3 to 1 ratio, and you can get a lot of segregation. And so in this case, we're using segregation to get the ball bearing from one end to the other. You're almost there? Oh wow. You didn't get a doctorate in bulk solids, did you? You should get one. Because it took me 2.5 weeks. Oh, you're onto something. So what we're trying to do is to segregate segregate the large particle to go from one end to the other. Okay, you're almost there. Come on. Who's going to win?
I think you, right?
Actually, the entertainment value is for you guys. I've already seen this. You're stuck. Who's ready to give up? Oh, come on. We have to kill another 7 minutes, so keep going. It's almost there. I want to help you out. Last bit. That's it. So there you go. It was that easy. So really what we're doing is we're segregating the material and we're getting the ball bearing from one end to the other. I could have told you that, but it wouldn't have been as much fun. So thank John and Ali. Thank you very much for your help. So those are, round of applause. So those are some of the things that I encounter day in, day out as a consultant. We see a lot of misunderstanding, misconception about the science of bulk solids. There's a lot of people that still think that it's a black art and that there's no real way of actually designing a handling system correctly. But I hope that I've demonstrated enough for you guys that there is science. I hope we had a little laugh, a little fun, and that you're able to remember this as you move on. If you have any questions regarding the principles that I use to do this hybrid Mythbusters magic show here, please talk to me now. Come see us at booth 1401. Thank you so much to my victims for your participation. It was great. And hope you have a good show. Thank you.